All right, today we are diving into one of the coolest space mysteries of the 20th century. Seriously, this is a cosmic detective story that had some of the smartest people on the planet questioning the very laws of physics.
So, our story kicks off way back in the early 1970s. We've got two main characters, if you will, these incredible spacecraft, Pioneer 10 and Pioneer 11. Their whole mission? Explore the outer planets, and then just keep on going, drifting into interstellar space. They were basically humanity's first messengers to the stars.
And you know what? For years, everything went exactly as planned. I mean, using good old Newton's laws of gravity, mission control at NASA could predict where these probes were going to be with just insane accuracy. They absolutely nailed it. It was this beautiful demonstration of how precise celestial mechanics really is. But then, as the probes got way out there, past the orbit of Saturn, mission control starts noticing something weird. A strange little discrepancy started showing up in the data. The spacecraft just weren't quite where they were supposed to be. Now, the difference was tiny, almost nothing, but it was always there. And it was growing. It was like some invisible hand was gently tugging on them, pulling them back towards the sun. A total ghost in the machine, an anomaly that, for the life of them, they couldn't explain with any known force in the universe. And this strange, unexplained slowdown? Well, this is where our detective story really kicks into high gear. Scientists gave it an official name, the Pioneer Anomaly. So what exactly was it? Well, put simply, once the spacecraft got past about 20 astronomical units from the sun, that's 20 times the distance from the Earth to the sun, they both started slowing down. Just a tiny bit more than all the known forces, like the sun's gravity or the solar wind could possibly explain.
And get this, scientists measured this phantom force with incredible precision. It was this constant sunward pull of about 8.74 times 10 to the minus 10 meters per second squared. Okay, I know, that's a ridiculously small number. It's almost meaningless on its own.
So let's put that in perspective. How small are we talking? Imagine you're driving your car through space. This force is so unbelievably weak that it would slow your car down by just 1 single kilometer per hour over a period of 10 years. But here's the thing. In the super clean, empty vacuum of deep space, this tiny, constant push was a huge puzzle. Okay, so you might be wondering, why only the Pioneer probes? That's a great question, and the answer is, their design just happened to be perfect for spotting something like this. See, they were spin-stabilized. Think of them like a perfectly thrown football, just spinning to stay stable. This meant they barely needed to fire their little thrusters to stay pointed at Earth. That gave them this incredibly clean flight path where a tiny constant force could actually be detected. Other probes, like the Voyagers, they were constantly firing tiny thrusters to adjust their position, which created a ton of noise that would have totally hidden a subtle effect like this one. So this is where it gets really interesting. How the scientific community reacted. They basically drew up a list of suspects, and these suspects fell into two very different and kind of dramatic categories. All right, so in one corner, you had let's call them the mundane causes. Maybe it was a tiny gas leak that no one noticed. Or maybe we just miscalculated the drag from the solar wind. Or, hey, maybe it was something as simple as heat coming off the spacecraft itself. But in the other corner, oh boy, that's where you had the really exciting stuff, the new physics theories. And this is what got everybody's attention. People started asking, could the Pioneer anomaly be the first real evidence of something profound? I mean, maybe our entire understanding of gravity was incomplete? That led to wild theories like MOND, which suggests gravity just works differently over huge distances. Or maybe, just maybe, this little anomaly was somehow connected to the expansion of the universe, or even to the mysterious pull of dark matter. For a while there, it really felt like we were on the verge of a revolution in physics. But there was a huge problem with all these exciting new physics ideas. Look, if there is some extra gravitational force pulling things toward the sun, it shouldn't just pull on the Pioneer probes, right? It should also be messing with the orbits of planets like Neptune and Uranus. But it wasn't. Their orbits were perfectly normal. For new gravity theory to work, it would have to affect a tiny little spacecraft, but not a giant planet. And that breaks a fundamental rule of physics called the equivalence principle, which basically says gravity has to pull on everything the exact same way, no matter how big or small it is. So, with new physics looking less and less likely, the detectives in this story turn their attention back to the scene of the crime, the spacecraft itself. And one of those mundane ideas, one that was dismissed early on, started to look more and more like the prime suspect, the probe's own heat. So there's this concept called thermal recoil force. Here's the deal. In the total vacuum of space, the only way a hot object can cool down is by radiating heat away as infrared light, as photons. But here's the kicker. Photons, even though they're massless, carry momentum. So if a spacecraft is radiating more heat in one direction than another, all those little photons shooting off create a tiny push in the opposite direction. It's basically like a microscopic, totally silent, continuous rocket engine.
Okay, so how would this actually work on the Pioneer probes? Well, they were powered by these things called RTGs, which are basically little nuclear batteries. And man, do they generate a lot of heat. All that heat has to go somewhere, so it radiates out into space. Now, if the design of the spacecraft meant that more of that heat was radiating forward away from the sun, then the recoil from all those photons would create a tiny, tiny push backward, toward the sun, which is exactly the direction of the weird force they were seeing.
But there was a major catch, and it's the whole reason this theory was dismissed in the first place. The RTGs, the power source, run on decaying plutonium. That means, over time, their heat output gets weaker, so any push from that heat should also get weaker over time. The problem? The first analyses of the anomaly showed the force to be perfectly, stubbornly constant. The theory just didn't seem to fit the facts.
So how on earth did they finally crack this case? Well, it took an absolutely heroic effort of what you could call digital archaeology. I mean, literally digging through decades-old data tapes to find the smoking gun.
Yeah, this investigation just kind of simmered for years, but the big breakthrough finally came in 2006. A super dedicated team managed to hunt down and digitize telemetry data from the entire mission. A lot of this stuff was stored on these ancient, hard-to-read magnetic tapes. Getting that data back was a huge win, and it gave them a much longer, more complete picture of what was really going on.
And this new data, it was the key to everything. For Pioneer 10, for example, the amount of usable tracking data they had more than doubled. It went from about 11.5 years to over 23 years of flight data. That much longer timeline was exactly what they needed to see if this mystery force was really constant or not.
And wouldn't you know it, when they crunched the numbers on this complete data set, the picture became crystal clear. A model that assumed the force was constant? Nope, poor fit. But a model where the force slowly decayed over time? It was a perfect fit. The smoking gun, the anomaly wasn't constant after all. It was getting weaker, exactly like you'd expect from the heat coming off a decaying plutonium power source.
So with this incredible new evidence in hand, the scientific community finally had its answer. That cosmic ghost force, well, it wasn't a ghost at all.
The big paper in 2012 that finally put this mystery to bed, led by a scientist named Turyshev, just said it perfectly. They concluded that once the thermal recoil force is properly accounted for, no anomalous acceleration remains. Just like that, the mystery was solved. The culprit was hiding in plain sight the whole time. It was the spacecraft's own warm glow.
So, in the end, the Pioneer anomaly didn't rewrite the laws of physics. But you know what? It's still a fantastic story about how science is supposed to work. It shows you how even the tiniest, most stubborn little puzzle can lead us to a deeper understanding. And it's a great reminder that sometimes the answers we're searching for have been there all along, just waiting in the data. Which kind of leaves you with a fascinating thought, doesn't it? What other cosmic secrets are just sitting there, hiding in decades-old files, waiting for someone to come along and rediscover them?